Is that object is going to move or not?
No, sir, it's not going to move because the net force is zero.
Yes, because equal and opposite force applied from equal means the 10 Newton, opposite means different direction. Okay, so when equal and opposite force applied on an object, okay, from opposite direction, so they cancel each other. Okay, that means when two forces acting on an object are equal and opposite, then it is called as balanced force. It is called as what? Balanced force. Understood? Okay. That means if any object is at rest condition, okay, if any object is in a rest condition, that means from all the possible direction, equal and opposite force is going to apply, right?
Yes.
That means no motion takes place here. No motion takes place here. But if you will apply force on that direction and its magnitude is higher, then motion is going to take place, right?
Yes.
Yes. Okay. So can we say that that particular object, if it is at rest condition, so it will remain at rest only, or if any object it is in motion, so it will remain at motion only until and unless any external force is going to apply on it, right?
Yeah.
Is it? Yeah, this is nothing but the first law of motion. Okay, so here we have the statement of first law of motion. An object continues to remain at rest or in a state of uniform motion along a straight line path unless an external unbalanced force acts on it. Okay, so whatever the force is going to act here, that must be unbalanced force. It must be unbalanced force. Understood? Yes.
Yes, sir. Yeah.
Okay. So, okay, that first law of motion is also called as the law of inertia. Okay, inertia is the state of an object in which it resists to change its state. Okay, is called as inertia. If it is in motion, so it wants to be in motion along with the straight line path only. Or if it is in rest condition, so it will remain at rest only until and unless any external force applied on it. Okay.
Okay.
Okay. Okay. So next part. Okay. Now we have second law of motion. Second law of Newton's second law of motion. You can. Okay. So the law states that, okay, first we have to understand what is momentum is. What is momentum? Is it related to momentum only, no? Yes. Okay, see, momentum is nothing but momentum is represented by P, and P means momentum is the product of mass and velocity, beta. Okay, mass and velocity. Therefore, P equals to M into V. Understood? So, what is momentum? Momentum is the product of mass and velocity. Okay. Keep replying, beta.
Yes, yes.
Okay. So, see here we have the momentum. It is represented by P. So, momentum is the product of mass and velocity of an object. Therefore, momentum equals to M into V. M is the mass and V is the momentum. Okay. So, the rate of change in momentum is proportional to the applied force. Okay. Suppose here we have any object. Okay. And it is in motion condition, beta. But its motion is maybe like slow, you can say. But if you will apply the force on it, okay, so obviously momentum of or the velocity of the object is increases, or maybe if you are going to apply force in that direction, so it will decreases, right? Is it? Is it or not?
Yes, sir.
Okay, suppose if you are, suppose this is the road beta, okay, and you are driving the bicycle here, okay, with the velocity of 10 kilometer per hour. I'm just taking example, okay, but your friend used to like reach there by bike, okay, and he is applying force on you from back side, okay, and let after applying the force on your bicycle, your velocity is increases by 20 kilometer per hour. That means your velocity is increases, na? Right?
Yes, sir.
So how much changes take place here? 10 kilometer per hour, na? Right?
Yes, sir.
So that the change in velocity is depend on the force which has been applied, right? More force, more will be the change. Less force, less will be the change. Right?
Yes, sir.
That means
Yes.
the rate of change in momentum, okay, is directly proportional to the applied force, right?
Yeah.
Yeah, so that we have here, the rate of change in momentum is proportional to the applied force. Okay, so I'm writing here, the rate of change in momentum means change in momentum is represented by generally delta p beta, delta p, okay, which is directly
Okay, sir.
proportional, yeah, directly proportional to the applied force means F. Okay. Now, rate of change in momentum means what? So delta P is nothing but the rate of change in momentum, and which is final momentum minus initial momentum. What is final momentum? Final velocity into mass. And what is initial momentum? Initial velocity into mass. Because we know mass into mass. Mass into velocity is nothing but the product, well, like momentum, na?
Yes, sir.
So, what will be the final momentum? Mass is constant, right? Mass is constant. So, mass into initial momentum. Initial momentum velocity is what? U. So, initial velocity into mass will be initial momentum is P1, and mass into final velocity is equals to P2, right? Therefore, change in momentum will be P2 minus P1. Okay. So what is P2? P2 is M into V minus what is P1? Is M into U. So we have M common. So I'm taking M common here. So what we have now? V minus U. Okay. And we are discussing about the rate beta. So rate of change. This is the change in momentum. Okay. So what we got? Change in momentum delta P equals to M into V minus U. Okay. Now, if we are discussing about the rate of change in momentum, so we need to divide both sides by T beta T. Okay, T. So now here we have rate of change in momentum, okay, is equals to M into V minus U divided by T. And we know acceleration equals to what? What? V
Yes, sir.
minus U divided by T, na? Acceleration. Rate of
Yes,
change in
sir.
velocity. Yeah. So instead of that over here, we can write A only. So we can write delta P divided by T. It is the rate of change in momentum is equals to mass into acceleration. Okay. And that rate of change of momentum is equals to force, applied force. So we can write force equals to mass into acceleration. So this is the formula we have for force, applied force, mass into acceleration.
Okay, sir.
Okay, more force, more will be the acceleration. Right? Is it?
Yes, sir. Yeah.
So here we have the derivation. Okay. Now we'll move toward the second law of motion. Okay, over here. No. This is the only second law of momentum. Like momentum, rate of change in momentum is nothing but the second law of motion beta. Which one? The rate of change of momentum is proportional to or directly proportional to the applied force. Okay.
Okay,
This
sir.
is the only second law of motion. Now third one. Third one is like again quite easy. Every action and a reaction force, okay, have equal and opposite
Reaction.
okay. Yes, every action force equal and opposite reaction force, and they act simultaneously. Beta. Suppose here we have the wall of the brick. Okay, that wall is made up of the brick. Okay, and suppose if you are going to punch here, beta, if you are going to punch over here, okay, so obviously you are going to hit the wall, so you will also get hurt by the wall, na?
Yes.
Means if you are applying force on the wall of 10 Newton, okay, then wall is also going to apply force on you by 10 Newton, okay, on opposite direction. Is it?
Yes, sir.
Okay. So here the every action force have equal and opposite reaction force, and they act simultaneously, beta. And they act simultaneously. When you will hit the wall, wall will also hit same time. Okay.
Okay, sir.
But this force, they are again equal and opposite. If you are applying force in this direction, the wall is going to apply force in that direction. But these force cannot cancel each other. Why? Why? Beta?
Okay.
Because they act on different object, not on the same object. In first
So can I
condition,
repeat it?
okay. See, in first case, they applied force of 10 Newton on the same object from opposite direction, right?
Yes.
So that force is applied on the same object. No, so it is going to cancel. But over here, you are hitting the wall, means your force is applying on the wall, and wall's force is going to apply on you. That means the force, okay, during the momentum, okay, acts on different object. That's why it is not going to cancel each other. Therefore, you get hurt.
Okay, sir.
Yes. So done all about the Newton's law of motion. Then we have law of conservation of momentum. You have it in your syllabus. Just do check.
Yes, sir. Just a second.